Here we go. We got 12, 13, 14, and 15. Find the inverse. The inverse function is pretty simple. You just switch x with y. Alright? So f inverse x is going to be well, when we talk about the inverse, what's happening here is this is y is equal to 2x minus 8. So we're just going to flip those y's. Okay, the y and the x. So this becomes this. And the y now becomes the x. So you can just go x equals 2y minus 8. And then we just want to solve. We want to solve for y. Okay, so we're going to add 8. So we get x plus 8 equals 2y, right? And then we want to divide by 2. Divide this whole thing by 2. That means each piece gets divided by 2. Everybody on the block still pay for the paper. Okay? So when you get done with this, you'll end up with 1/2 x plus 4 equals y, right? And that's your new inverse. So your inverse function of x is actually equal to 1/2 x plus 4. And this is the inverse of that. So again, to start that off, you just need to switch the x's and the y's. So you're just going to switch that around and solve for y. Okay? Logarithms. This brings us back to chapter 4. Alright, so we should be able to look at, this is exponential form, right? So we have the base, we have the exponent, and it equals the number. Okay? And then when we want to put it in logarithmic form, we have a log of the base of a number is equal to the exponent. And so what we can do is just use this, my base. So I have log base 2. Okay? My number is 32, and that equals my exponent, which in this case is 5. So 2 to the 5th is 32. 2 times 2 times 2 times 2 times 2 is 32, right? But the log base 2 of 32 is 5. Okay? This just goes back to that basic logarithm that we did. Now, using the rules of condensing, we want to look at this and say, okay, subtraction in our power rules, right? In our exponential rules, we have, when we subtract, we are dividing. Okay? So when we divide powers, we end up subtracting exponents, right? But a logarithm is an exponent. So when we're subtracting exponents, what we're really doing is dividing the power. So it makes it really quite simple. Subtraction is division, so I got log base 3 of 27 divided by 3. Okay. So if I want, I could go further. 27 divided by 3 is equal to log base 3 of 9. Right? And if I thought about that, 3 to what power is equal to 9?
Oh, 7. second.
Yeah. So log base 3 of 9 is equal to 2. Okay? Alright, so this can condense all the way back down to 2. Okay? Now, if we want to solve something like this, we want to use those condensing rules. Right? So our condensing rule is that log of 12x cubed is divided by, because it's subtracted, by 3x squared. And that's going to still equal 2. Now, 3 goes into 12 4 times. If I take 2 from 3, I leave 1. So log of 4x is equal to 2. Okay? And so what is the base of this log? If there is no base showing, do you remember what the base is?
It's 10.
Yes. So it is a base 10 system. And so now if we want to plug that back into exponential, we want to plug it back into that exponential property, we can say the base is raised to the exponent and it is equal to the number. And now it's pretty easy to solve. 100 is equal to 4x. And if I divide by 4, then I get 25 is equal to x. And there it is. All right.
Good job, Dan.
How did we do? Questions? We went pretty fast. If you have any questions, I can go back over it before I stop the video. No?